Welcome to the DIY Honda Garage channel. This presentation focuses on the Diagnostic Trouble Code P0108, which indicates a problem with the Manifold Absolute Pressure (MAP) sensor circuit in the Honda Accord models from 2012 to 2017. The MAP sensor is critical as it measures the pressure or vacuum in the intake manifold. The data collected by the MAP sensor is converted into an electrical signal that is sent to the Powertrain Control Module, or PCM. This information is essential for the PCM to efficiently monitor engine performance and make real-time adjustments. A malfunction in this circuit can lead to a high-voltage output from the MAP sensor, triggering the DTC and illuminating the malfunction indicator lamp, or MIL. This could potentially affect the vehicle's performance and emissions, making timely diagnostic and repair actions vital. After all necessary repairs and interventions are complete, it is essential to conduct a final repair verification for DTC P0108. Begin by clearing the DTC using an appropriate scan tool, which resets the PCM and allows the monitoring cycle to begin anew. Following this, a test drive of the vehicle is advised to confirm that the repairs made have effectively resolved the issue. During the drive, closely monitor parameters and watch for any signs of the DTC returning. If the DTC does not reappear after multiple drive cycles, the repair is considered successful. Continued monitoring is essential, as transient issues can sometimes emerge after initial repairs. Preventive maintenance is key to avoiding future occurrences of DTC P0108 and ensuring the longevity of your vehicle's performance. Regular inspections of the MAP sensor and associated wiring can help identify any emerging issues before they lead to DTC activation. Keeping electrical connections clean and free from corrosion is vital for ensuring optimal conductivity. Additionally, maintaining the integrity of the vehicle's vacuum systems can prevent pressure anomalies that may affect the MAP sensor's readings. Scheduling routine checks as part of a comprehensive maintenance plan can clarify potential faults, thus preempting costly repairs down the line. Being proactive about vehicle maintenance contributes to better reliability and fuel efficiency. In conclusion, DTC P0108 signifies a malfunction within the Manifold Absolute Pressure sensor circuit, which could have serious implications for vehicle performance. A methodical troubleshooting approach should be adopted, focusing on the MAP sensor wiring, the sensor's functionality, and the PCM's internal circuits. By systematically identifying the root cause, effective repairs can be made to restore the vehicle's proper function. Additionally, implementing a preventive maintenance plan can significantly reduce the likelihood of encountering this DTC in the future. This comprehensive understanding of DTC P0108 emphasizes the importance of timely diagnostics and proactive care for the Honda Accord to ensure overall vehicle health. The error associated with DTC P0108 pertains to the performance of the Manifold Absolute Pressure (MAP) sensor, located on the intake manifold. This sensor is responsible for measuring the pressure or vacuum within the manifold, providing vital data to the Powertrain Control Module (PCM). The PCM interprets this data to optimize engine performance. When the MAP sensor outputs a voltage that exceeds a predetermined threshold, specifically 4.49 volts or more, for a minimum duration of 2 seconds, the PCM recognizes this as a malfunction. In such a case, the MIL will illuminate, and a DTC is recorded in the memory of the PCM. The effective functioning of the MAP sensor is critical for the vehicle's overall performance, as any abnormal readings can lead to suboptimal engine operation. When diagnosing DTC P0108, several possible causes should be considered. First, A PB line open indicates that there may be a break or disconnection in the sensor's power battery line that can prevent proper operation. Next, if the SG line from the map sensor is open, it means that the sensor may not be communicating effectively with the PCM, leading to erroneous voltage signals. Thirdly, a failed map sensor itself could produce unreliable data that triggers the DTC. Lastly, a malfunction within the PCM's internal circuits could also lead to incorrect readings. It is essential to verify each of these components during the diagnostic process to determine the root cause effectively. Identifying the symptoms of DTC P0108 is crucial for timely diagnosis and repair. The most immediate symptom is the illumination of the malfunction indicator lamp, MIL, on the dashboard, which acts as a visual alert to the driver. Additionally, the vehicle may experience poor engine performance, evidenced by sluggish acceleration or rough idling, as the PCM struggles to optimize fuel delivery based on inaccurate manifold pressure readings. Alongside performance issues, increased emissions can occur due to improper fuel-air mixture adjustments. Finally, the presence of the Diagnostic Trouble Code will be confirmed when a scan tool is used, providing a clear identifier of the map sensor circuit issue. For the initial troubleshooting step related to DTC P0108, it is important to confirm that the ignition switch is in the on position. This step ensures that electrical systems, including the map sensor and PCM, are powered, allowing them to function correctly. If the vehicle is equipped with a keyless access system, it is essential to have the engine start-stop button in the on mode. This setup enables the diagnostic monitors to execute and assess the system to determine if the DTC is present. Properly setting the ignition conditions is a fundamental prerequisite before proceeding with further testing. The second troubleshooting step involves checking for any active or pending diagnostic trouble codes. This is crucial because the diagnostic monitor may not run if other active trouble codes are triggered, which can impede your ability to assess the map sensor circuit. If there are other DTCs present, they should be addressed first to ensure that they are not contributing to the problem at hand. A clean diagnostic environment, free from pending codes, increases the reliability of the troubleshooting process. After resolving any other active DTCs, you should then retest for the specific P0108 code to see if it still persists. In the third step of troubleshooting DTC P0108, a thorough inspection of the wiring associated with the map sensor is necessary. Check for any visible damage, such as frayed wires or corrosion on the terminals, which could lead to poor connectivity. Specific attention should be paid to the power, PB, and signal, SG lines to ensure that there are no open circuits. The condition of these lines directly affects the map sensor's ability to send accurate data to the PCM. If any wiring issues are identified, repairing or replacing those components could resolve the DTC. Once repairs are made, it is vital to retest to confirm that the circuit is functioning correctly. The fourth step is to test the functionality of the map sensor itself. Using a multimeter, measure the output voltage of the map sensor while the engine is running. Ideally, the voltage should vary according to changes in manifold pressure, reflecting accurate readings during throttle operation. If the voltage remains constant at a high level, this would indicate that the map sensor is faulty and may need replacement. Additionally, if the readings do not match expected values during different engine conditions, further diagnostics or sensor replacement may be necessary. Confirming that the map sensor is functioning correctly is essential to establishing the overall health of the intake manifold pressure measurement system. In the fifth troubleshooting step, the focus shifts to the powertrain control module's internal circuits. Since the PCM plays a critical role in interpreting the data from the MAP sensor, any malfunction within the PCM could lead to erroneous DTC readings. Inspecting the internal circuits requires advanced diagnostic skills and possibly specialized equipment, as any faults may not be visible externally. If the PCM is suspected to be the source of the issue, it might need reprogramming or replacement. This step is more complex and should typically be performed by professional technicians trained in electronic control units. Careful analysis during this phase can help determine whether the issue lies with the PCM itself or elsewhere in the system. Please like and subscribe to the channel. See you next time.